Good morning, children. I welcome you all to a new class in physics. And if you remember, in the previous class, we had studied about Vernier calipers. And I told you that Vernier calipers is a device which has a least count of 0.01 centimeters. Okay, it means that it could successfully take a measurement of around 0.01 centimeters. Now there is another instrument today which we are going to study today, and that's the screw gauge. Okay children, I'll show it to you. This is how a screw gauge looks like. It is an instrument which can measure accurately up to 0.001 centimeters, even below Vernier calipers. It can take an accurate measurement up to 0.001 centimeters. If you take a meter scale, it can measure accurately up to 1 millimeter. If you take a Vernier calipers, it could make an accurate measurement up to 0.01 centimeters. And if you take the screw gauge, it can take a measurement accurately up to 0.001 centimeters, children. Okay, now we will study about the screw gauge. I will pick up the model of the screw gauge because it's a bigger version of the actual screw gauge. This is the bigger version. Okay, so that you can see clearly. I'm using this. I will explain you the different parts, children, of the screw gauge. Okay, now you can see this part which I'm using to rotate. Okay, this is known as the ratchet part of the screw gauge. It is used to rotate the circular scale. If you remember, in the Vernier calipers, I told you there are two scales: main scale and Vernier scale, right? Main scale was just like a normal scale, and Vernier scale had 10 divisions. Now here you again have two scales, the main scale and the circular scale. Okay, the main scale and the circular scale. Now when I rotate this, can you see there is a scale which is opening up here. There is when I rotate this ratchet, I am exposing a sleeve. I am exposing a sleeve which is the main scale over here. It is marked in mm. It is marked in millimeters. Okay, and this is the main scale, and this circular ring over here is the circular scale. It has 100 divisions, children. It has 100 divisions. So 100 divisions circular scale, and the main scale may be around, say, 10 millimeters, 15 millimeters, or maybe 5 millimeters, because screw gauge comes in different sizes. Okay, so it has two scales, the circular scale which has 100 divisions. It could also have 50 divisions. It could have 20 divisions on the circular scale. It is of different types, right? But this particular screw gauge has 100 divisions on the circular scale, and the main scale has around 10 millimeters or maybe 5 millimeters. Okay, so I told you this is the ratchet part of the screw gauge. Then you can see this part. This is known as the stud part of the screw gauge. This part of the screw gauge is known as the spindle. Okay, and these you can see, this is the screw which is having those cuts and grooves, right? Okay, and as I told you, the stud part, the spindle part, okay, the screw part, the main scale, the circular scale, the ratchet, okay, and you can close it also, you can open it also. Okay, right? So these are the different parts of the screw gauge. Now let us see what is a screw gauge used for. When you open the screw gauge, this particular screw gauge is used to measure the thickness of a particular given object. You can see, this is a particular needle. I will fix the needle in between the stud and the spindle like this. Okay, 1 minute, let me open up. I will fix it for you and show it to you. You can see here. Children, did you see how I fixed it? So I can measure the thickness of this needle from at different points. It could also, this is so accurate that it can measure the thickness of a sheet of paper or a metal sheet. In metal industry, when you go to buy a metal sheet, it can measure the thickness of that particular metal sheet, and it can be measured accurately. Okay, so this is how a screw gauge is used. Now let us look at certain things. A screw gauge has a pitch. Now what do you mean by pitch? Pitch is the distance moved on its axis by the screw in one complete rotation of the head. Now you can see once again, 1 minute, I will just show it to you children. I will just again show it to you. Now this was the model which I took. Okay, now I'll close it completely, right? I'll close it completely. Now I've closed it, right? Now when I rotate it one by one complete rotation, when I give it one complete rotation and the main scale opens up, right? Now that reading of the main scale which opens up on one complete rotation of the circular scale is called as its pitch. Okay, that is the pitch. Now how can I find out the least count of this given screw gauge? I can find out the least count by using the formula pitch of the screw divided by the total number of divisions on the circular scale. Now normally when you open up when you give one complete rotation to the circular scale, the pitch of the screw is normally 1 mm. It is equal to 1 millimeter. When you take one complete rotation of the circular scale, the main scale reads 1 mm. So that's the pitch. So if I want to find out the least count of the given screw gauge, the formula is pitch, that is 1 mm upon total number of divisions. And I told you children, the total number of divisions of circular scale is 100. So that will be 1 mm upon 100 divisions, which works out to 0.01 mm. Or if I want to find out the answer in centimeters, it will be 0.001 centimeters. So children, what are we looking at? We are looking at this value. Can you see this value children? This is the least count of the screw gauge. Okay, the least count of the screw gauge is equal to 0.01 mm or 0.001 centimeters. And what is this least count? It is the minimum or the smallest accurate measurement that can be taken with the help of this screw gauge. That is its least count. Okay. Now after understanding how to calculate the least count, let us see how can we take a reading with the help of this screw gauge. I'll try to explain it to you, right? Now, I have picked up my screw gauge. I am closing it completely, okay, and I now open it up, right? I will take the needle, I will fix it here, okay, like this. I'm going to fix it up for you, okay. Just a minute please. Yes, now I can fix up this needle at a particular point. I have fixed it up like this, right? Can you see? I have had a grip over this object. This is a metallic needle. Make it a point that it points away from your body because you have to be safe. It might hurt you. So you fix it up in a manner. Okay. Now here, I fixed this. Now when I want to take the reading, what am I measuring? I am measuring the thickness. I am measuring the thickness of the needle provided, right? That will be equal to main scale reading plus circular division coinciding multiplied by least count. Now this is the formula of how to calculate the thickness of the needle. I will take the needle, I will fix it. Okay, I will fix the needle between the stud and the screw. I'll fix the needle and now I want to take the reading, observed thickness. That will be main scale reading. I will read it. When children, I'm trying, you won't be able to see because it's a very small instrument, but I can see, I will let you know that when I'm fixing this needle, the main scale has opened up. This is the sleeve, the hidden main scale has opened up and I'm reading it as 1 minute, I'll let you know, 6 millimeters. Okay, so 6 millimeters I have opened up here. So what is my main scale reading? It is 6 mm. Okay, because that division has opened up, right, when I fixed this object. First it was closed, so it was at 0. But when I fixed this needle, it has opened up to 6 mm. That is my main scale reading. Plus circular division coinciding. Now there are 100 divisions. Now I have to see which out of 100, 10, 20, 30, 35, 45, which division is coinciding with this baseline. Baseline means the main scale. Okay. Now here I can see that the 12th division is coinciding. The 12th division of my circular scale is coinciding with the main scale. So that will be the circular division coinciding. Multiply. What was the least count, children? I calculated in mm. In mm, that was 0. 0 was, what was the reading of the least count? I told you it is 0.01. Yes. So it is 0.01 mm. That is in mm. Okay, not in centimeters. Had it been in centimeters, had this been in centimeters, I would have taken 0.001 centimeters. Okay, so it should be of the same unit, right? So now I'll calculate 6 mm. That is my main scale reading, 6 mm, plus this would be 0.012 in mm. Okay, this will be 0.12. Yes, not 0.12, it will be 0.12. And when I calculate this, it comes to 6.12 mm. So this is my final answer. I have found out the thickness of this particular needle. So this is how we can calculate, children. Okay, you can see it is main scale reading plus the circular division coinciding multiplied by the least count, and you get the answer. But this is your observed thickness. Now, this particular screw gauge can have a zero error. It can have a zero error. It cannot, it may not have a zero error. It may have. Now, let's look at that now. Okay. Now, the zero error, we have to study about what is the zero error and what are the types of the zero error. Okay. So, I am writing it down. Zero error could be of two types. It could be a positive zero error. It could be a negative zero error. Now, what is positive and what is negative? In order to find out the zero error, I'll completely close it. I'll completely close this screw gauge, right? And I will see that, you know, I told you there are two scales. One is the circular scale in the center and the other is the main scale hidden down, right? When the zero, listen carefully, when the zero of the main scale coincides with the zero of the circular scale exactly, then it does not have an error. When the zero of your main coincides with the zero of your circular, there is no error. But when the zero of your circular scale lies below the zero of your main scale, like let us suppose this is the zero of the main scale, and when I close it, the zero of my circular is lying below the zero of the main. Okay, so when the zero of the circular lies below the zero of the main scale, it is said to have a positive zero error. Okay, so let me write down. I'll use keywords, children. I'll use keywords. That is, zero of circular scale lies below zero of main scale. Okay, so it is a positive zero error. That is this. Now, when there is a positive zero error, how do you calculate? You use the formula for zero error. You use the formula circular division coinciding multiplied by least count. This is what you use to find out the positive zero error. Circular, if the zero is not coinciding, it is lying below, then which division is coinciding? Let us suppose the 12th division is coinciding. So you will find out it has 12 into 0. You will find out in mm. So it will be 12 into 0.01, and that will be 0.012 mm. So this way you can calculate the positive zero error. Okay, you can calculate the positive zero error. It will be 0.12 mm plus 0.12 because it is positive in nature, right? On the other hand, when the zero of your circular, when you close it completely, and if the zero, I told you this is the zero of your main, and now the zero of your circular is like above, okay? So you will say when the zero of your circular scale lies above the zero of your main scale. Above the zero of your main scale, it is a negative zero error. And how do you calculate it? It is given by the formula. I'll write down here. I'll write down 100 minus circular division coinciding. In order to find out the negative zero error, it is 100 minus the circular division coinciding multiplied by least count. Okay. So children, once again, just listen carefully. When the zero of your circular lies below the 0 of your main, it is a negative 0, it's a positive 0 error, below is positive, and when the 0 of your circular lies above, then it is negative 0 error. How do you calculate your positive 0 error? Circular division coinciding multiplied by least count. How do you calculate your negative 0 error? 100 minus the circular division coinciding multiplied by least count. Okay? Don't forget the formula used, right? And suppose if in case of a negative, there is the 60th division which is coinciding, 60th. So how will you calculate? You will say 100 minus 60 into the least count, that is 0.01. Okay, and that will be 40 into 0.01. And this way, whatever answer you get, you will minus 0.04 mm. Right? So when the error is positive, it is written as plus, and when it is negative, it is minus. And this is how you find out the 0 error of the particular given screw gauge. Now, when after finding the 0 error, where is it used? It is used to find out the true thickness. Okay, it is used to find out. See, we had already found out the thickness. Okay, we had already found out the thickness, but that was an observed thickness. And if you are supposed to find out the true thickness of your given needle, that will be equal to observed thickness minus 0 error with sign. This is very important, with sign. It has to be always taken with sign. Okay, now suppose if your observed thickness was 6.04 mm, suppose, and you have a 0 error of say minus 0.04 mm. So in that case, your actual reading would be 6.04 plus, because minus and minus is plus, 0.04, and that works out to 6.08 mm. And if it was a positive 0 error, then you would have subtracted it. Right? It is negative, so minus and minus becomes plus. So remember, children, that in a screw gauge, you are only able to find out the thickness of the object, given object, and you have the main scale reading, okay, plus the circular division coinciding into least count, that will give you the observed thickness, but your true thickness will be found out after calculating the 0 error. Okay, so this is how we are going to we use our screw gauge.